Simultaneous linear equations. So solving a pair of simultaneous equations means finding the pairs of values, or the linear equations, it'll be the pair of values of x and y that satisfy both equations. So we're looking for an x value and a y value that fit both equations. Consider the equations y equals x minus 1 and y equals 2x minus 3. So I'm going to tell you that the solution of these equations is x equals 2 and y equals 1. That's the simultaneous solution. So that means that for both of these equations, when x is equal to 2, y should be equal to 1. So let's just check that. So the first equation is y equals x minus 1. So when we let x equal 2, we get y equals 2 minus 1, so y is equal to 1. So therefore x equals 2, y equals 1 fits the equation, which graphically means that the point 2, 1 is on the line. Thinking about the second equation, y is equal to 2x minus 3, when x is equal to 2, y will be 2 multiplied by 2 and minus 3. So we get 4 minus 3, which is 1. So therefore, x equals 2, y equals 1 fits the equation, which tells us that the point 2, 1 is on the line. So thinking about this graphically, what we're actually doing here is we're finding a pair of x and y values that fit both equations, which means we're finding a point which is on both lines, which means what we're finding is the point of intersection between the two linear graphs. So we can use a graphical method to solve simultaneous equations. It is quite limited because it relies on accuracy. Really only, you should really draw your graphs on a grid if you're going to read the solution off correctly. And really it's only going to be accurate if your solution is a pair of whole number coordinates. If the simultaneous solution was 1.85 and 7.924, a graphical method without technology is not going to really be useful. Just to get the point though as to what's going on, let's have a look at solving a pair of simultaneous equations graphically. So we want to do this by first sketching each of the lines, and then we should be able to state the solution to the simultaneous equations. So the first line is y equals 3 minus 2x. Clearly has negative gradient, so it's going to slope down. Its y-intercept, when we let x equal 0, is clearly going to be y equals 3. And our x-intercept, so we'll let y equal 0, add 2x to both sides, and divide by 2. So x is 3 on 2, or 1.5. So we have an x-intercept at 1.5 and a y-intercept at 3. You'll also note you've got a gradient of negative 2, so given that you're trying to find the point of intersection, it might not be a bad idea to sort of step out that gradient a bit. So for every 1 across, 2 down, for every 1 across, 2 down, every 1 across, 2 down, just so your graph is nice and accurate. So the line y equals 3 minus 2x goes through all of these points. Obviously I'm not able to use a ruler here, so we'll try that last bit again. Not able to use a ruler here, so my graph is not as straight as I'd like it to be, and therefore we might have some problems. So our second equation is y equals x minus 3. So the y-intercept is clearly at negative 3. When we let x equal 0, y will equal negative 3. The x-intercept, we'll let y equal 0. And so adding 3 to both sides, x is equal to 3. So we have a y-intercept at negative 3 and x-intercept at 3. You can see we have a gradient of 1, which means that for every 1 across we go 1 up. And actually when you start to step out the gradient, you can see that your solution is going to be here. And so we draw in our line. And so we can see that the solution of the equations is going to be where the two lines cross. So that's happening here at this point, 2, -1. So the simultaneous solution, or the solution to the simultaneous equations, is x equals 2 and y equals -1. So simultaneous equations certainly have a graphical application, and that's important for you to understand. We can use graphs to solve them, but there are quite large limitations to them. To that method. Obviously, if you had technology, you could use find the point of intersection of two graphs. But again, depending on the technology you use, certainly if you're using the TI Inspire CAS, if you use a graphical method, you're only going to get a decimal answer. So your solution will be in decimals, which if you need to give an exact answer and it's not a very nice fraction, that's going to be kind of difficult to work with. But shouldn't be a problem if your answers are nice and straightforward, whole numbers or simple fractions.